right, so continuing on with optimization. Okay, the next one says a printer needs to make a poster that will have a total area of 200 square inches and will have a 1-inch margin on the sides, a 2-inch margin at the top, and a 1.5-inch margin on the bottom. What dimensions will give the largest printed area? Okay, I put this question on the in-class test last year. So a question just like it on the in-class test, and people missed it. So I pay attention. All right, so draw a picture first. So a printer needs to make a poster that will have a total area of 200 square inches. Okay, so we have our poster. Total area is 200 square inches. Has a 1-inch margin on the sides and a 2-inch margin at the top, and a 1.5 at the bottom. Oops. So this is 1.5. This is 1. And this is 2. It's not really drawn very well. 1.5 should be a little bigger, right? So what dimensions give the largest printed area? So I would probably make this inside part X and Y. Now you can do it the other way. Like you could make the outside X and Y and then subtract. That's fine. That works as well. Actually, I'm wondering. Actually, let's go ahead and do it that way. I'm lying. It doesn't matter, but I think the outside part might be a little easier because you were given the total area of 200 square inches. A lot of times it will say like the printed area is 200 square inches. Okay, so let's make this X and this Y. Okay, so we know that X times Y equals 200 because the total area of that poster is 200 square inches. So is there a way I can relate Y and X? Like how can I replace X, or replace Y? What can I replace it with? Right, so Y equals 200 over X. So we want all of our variables to be in one, or yeah, we only want one variable, right? So 200 over X. Okay, so now we want to maximize the largest printed area. So I'm going to call that A for the largest printed area. So think about what your largest printed area is. We had X before, but now I've subtracted out the top part and the bottom part. So I've subtracted out how much? 3.5, right? So I'm going to have X minus 3.5. And then I had 200 over X, but now I subtracted out 1 and 1, right? So I have 200 over X minus 2. That's minus 2. Okay, that's what you're trying to maximize. So you're trying to find the largest printed area, so maximize A. So let's multiply first. So I'm going to have X times 200 over X, so I get 200. My outer is minus 2x. My inner is negative 3.5 times 200 over x. So that's negative 700 over x. So I'm going to write negative 700x to the negative 1. And then my last is negative 2 times negative 3.5, so plus 7. So you end up with A equals 207 minus 2x minus 700x to the negative 1. Okay, take the derivative. So A prime equals, derivative 207 goes away, derivative of negative 2x is negative 2, derivative of negative 700x to the negative 1 is plus 700x to the negative 2. Set it equal to 0. Okay, when you have denominators, go ahead and get common denominators. So multiply the negative 2 by x squared over x squared. So I get 700 minus 2x squared over x squared equals 0. Okay, your critical points come from when the denominator is equal to 0 and when the numerator is equal to 0. So the denominator equals 0 at 0. And that makes sense that that's a critical point because if I had x was 0, you don't have a poster at all, right? Just have a straight line. Doesn't make any sense. Okay, so solve for when the numerator is equal to 0. So you get 700 equals 2x squared. Divide by 2. So I get 350, and then I'm going to take the square root. So I get x equals 18.708. Okay, I'm going to guess that you're going to use that over again. Like you're not just going to use that one time. So I would store that number. Do you guys remember how to store?
No.
So hit stop.
Why can't the 18.708 be positive or negative?
It can be positive or negative, yes. But since this is like a real life problem, you're not going to have a negative for a length. So it's just the positive one. All right, now it's stored as A. And then write that you've stored it as A. So like write parentheses A or something so you know that that's now A. Oops. Okay, now we're testing in the derivative. So you can test right here if you want. And you're going to test like 1. So 700 minus 2 all over 1. So that's positive. And if you test anything more than 18, it would be negative. So it's going up and then down. That's why you're maximizing, because that's a maximum point there. It was increasing then decreasing. All right, so x was your, x equals 18.708. That's one of the dimensions, and it's in inches. And then the other one, you need to do 200 divided by that number. So 200 divided by A. So you get 10.690. Yeah, that's right. So see how this was 200 over x? So I did 200 divided by A. That was stored in the calculator. So I got 10.690.
You got 18.7 because the x over.
Yeah, because that was A. So that's these two measurements. So those are your dimensions. Now, if they ask for the total area, then you would multiply those to get the area. They could ask lots of things. Like you could say for each square inch they charge 1 cent. So what's the total cost? You know, there's lots of things you could ask about this. All right, number 5. So a window is being built, and the bottom is a rectangle, and the top is a semicircle. This is called a Norman window. I think you have one like this in your homework, where it talks about a Norman window. Okay, so you have a rectangle on the bottom, and then you have a semicircle on top. Oops, my semicircle didn't look very good. Reminds me of a basketball court. So have you seen these Norman windows before? They look like this. Okay, so there are 12 meters of framing material. So that means going all the way around, you have 12 meters. What must the dimensions of the window be to let them in the most light? So what does that mean, to let in the most light? What am I maximizing? Area, right? Okay, so first we need to figure out this 12 meters of framing material thing. Okay, so I'm going to call my bottom, let's just call it x. Now that means the bottom of the semicircle is x. So how can I find the distance right here that I'm drawing in red? Yeah, it's like you take the circumference, but it's divided by 2. So instead of having 2 pi r, it's pi r, right? Well, what is r? Let's make this a little easier. Okay, let's make this 2x on the bottom. So that way r is just x. This will make our numbers a little nicer. Okay, so my radius is x now, so that means that I have half of 2 pi r. So it's just pi times x. So going around here, it's pi x. Then I have y and y. So my frame is made by half of the circumference, so pi times x, plus y plus y plus 2x. And I know I have 12 meters for that frame. So pi x plus 2y plus 2x. Okay, what's my next step? What do I need to do? Yeah, you need to get rid of the y. Like, you need to be able to just have everything in x. So that way we can take the derivative with respect to x with only one variable. Otherwise, we could do implicit differentiation, right? If we had y's. We'll get to that later. That's called related rates. Yes?
Does there need to be 4x's since we said like the width equal to 2x and there's two of those?
Okay, but you don't,
Or is there
there's
not?
nothing there. That's
Okay,
all
I
just one
always
window. Yeah, it's kind of confusing. So let's draw this dotted, maybe so you can see it better. Okay. So solve for y, so I'm going to have 12 minus 2x minus pi x equals y, or 2y. Now I'm going to divide everything by 2. So I'm going to get 6 minus x minus pi over 2x equals y. Okay, now we start on the area. So my area of this whole window, sorry. Use my sleeve. All right, so I have a rectangle and a semicircle, so that's how I'm going to come up with the area. So the area is going to be 2x times y, so y we just replaced. So I'm going to have 2x times 6 minus x minus pi over 2x. So that's just the rectangle, plus half the area of the circle, because it's a semicircle. So area of circle is pi r squared. So what am I going to have? Pi over 2 x squared, right? So plus pi over 2 x squared. So multiply the 2x in, so I'm going to get 12x minus 2x squared minus, that 2 is going to help us a little bit, so it's going to be pi x squared.
Why is it pi over 2 then? Because you said pi squared.
Yeah, because it's just a semicircle. So you need pi over 2. So you really have 12x minus 2x squared minus pi over 2x squared, because I had negative pi plus pi over 2. You guys with me? Maybe a little scrunch too. Let me write it a little below. Okay, so I have negative pi x squared plus pi over 2 x squared. So combine them. So if I had negative pi plus pi over 2, so it's like negative 1 plus 1 half. So negative 1 half. So I get negative pi over 2 x squared. Still with me? Do I need to go over that again? Just fractions. All right, so a prime equals 12 minus 4x minus, I'm going to have pi over 2 times 2, so pi x. I want to find when it's equal to 0. So I'm going to write this as 12 minus, and I'm going to have 4 plus pi x. So I just pulled out the x. So subtract the 12 over. So I get negative 12 equals negative 4 plus pi x. So that's plus and plus. So it's whatever 12 is divided by 4 plus pi. Now make sure if you're putting this into your calculator, so if you're finding the decimal answer, you put 4 plus pi in parentheses. So you should get x equals 1.680. Store it just in case you need it, so store as a. So write a next to it. So the question is, what must the dimensions of the window be in order to let in the most light? Yeah, so I'd say like, so multiply by 2, so it'd be 3.361 meters along the bottom by oh gosh, that's not 1.680. So what do I need to do for y? Do you guys see how I got 3.361 first of all? So just multiply by 2. So that finds this length here. All right, how do I find y? What do I need to do? Plug in here, right? 6 minus, so plug in a. So 6 minus a, see why we store? Minus pi over 2a. Make sure you're using your pi button too. Some people keep using 3.14. Oh, interesting. 1.680, same as a. So those are the dimensions. Okay, I would probably check very quickly to make sure that that is a max. You know, put it on the number line. Say, okay, if this is a prime, and I had 1.680, if I plug in 1 into the derivative, so here's the derivative. If I plug 1 in, I get 12 minus 4 plus pi. That's positive. If I plug in 2, I get a negative, so it was increasing and then decreasing, so that is a max.
What about the half circle part? You didn't include it.
It's in there. What do you mean it's not included? Like in the area?
You did the y and the x, yeah.
Yeah, well, it's automatically, it has to be that dimension, right? Because it was on the top of the rectangle.
No, but what I'm saying is that you only included x and y.
I know, but that semicircle is already included, because if this was, so if that was x and x, so that 2x was 3.361. This is the only semicircle that can have that diameter. So it's already, like, it's in that problem. You just don't have to write it.
The 3.361 is part of the curve.
No, it's right here. So you're saying, why don't you need to write what that curve is?
Yeah.
It's already included, because if I have a diameter of 10, there's only one semicircle that I can draw that has a diameter of 10. If I have a diameter of 15, there's only one that I can draw that has a diameter of 15. So it's perfect semicircle on top of that rectangle. Yes, Kat? Right here?
Yeah, or above it, either one. Or, yeah, like, we have a equals 2x times 6 minus x minus pi over 2x.
Okay, that was the area right here. So how do you find area? What equation do you use? So area of a circle would be pi r squared. What's our radius? X. So I have pi x squared for the whole circle, but I only have half a circle. So it's pi over 2 x squared. Yeah, it's like pi x squared. That was the whole area of the circle divided by 2. So I just wrote it as pi over 2 x squared. Same thing. All right, so some more profit stuff. Okay, so profit equals revenue minus cost. And average cost, remember, was your total cost divided by your number of items that you had. Remember all this? So we have some more problems like this. Okay, so it says, suppose that your revenue is 9x and your cost is x cubed minus 6x squared plus 15x, where x represents thousands of units. So what is the average cost for 100 units? So average cost, remember that's C bar. So it's your total cost divided by your number of items. So your average cost for 100 units would be whatever C of 100 is divided by 100. So you find C of 100. You do 100 cubed minus 6 times 100 squared plus 15 times 100 divide by 100. You can make it easier by taking the 100 into each piece. Do you see how I'm shortcutting this? So if I take the 100 into each one, I'd have 100 squared minus 6 times 100 plus 15. So 100 squared is 10,000 minus 6 times 100, so 600 plus 15. So I just kind of shortcutted. You don't have to do that, but. So 9415. Okay, so that's the average cost for each item. You with me? You don't have to bring the 100 in. You can do it the long way. So they're making something expensive. I don't know. Maybe they're making a car. So that's the cost of producing a car. All right, so B, what is the cost of producing the 100th unit? So when you hear that, remember you need to figure out how much it costs to create like the first 99 items, and then the cost that it costs, the cost that there was to make the first 100, and then you subtract them. That would be just the additional 100th unit. So you do 100, so C of 100 minus C of 99. So this is the cost of first 100 units. This is the cost of first 99 units. Ah, gosh, I hate how it does that. Okay, so does that make sense? So that would be the cost of producing just the 100th car, or whatever this is. Okay, so C of 100. You can make this easier on yourself and put C in for your Y1. And then go to table. So 100 and 99. So when I plugged them into my table, I got C100 was 941,500. So 941,500. Subtracting out 912,978. So 912,978. Then I subtract the 2. That 100th item got expensive. So maybe they're paying people overtime or something like that. I don't know. They didn't have enough resources, so they had to ship some things in. Yeah. So that car is much more expensive. All right. All right, so is there a production level that maximizes the profit? If so, what is it? Okay, so profit is the revenue minus the cost. So we've talked about like the lemonade stand. So revenue is the total amount of money you have in like your cup at the end of the day. Subtracting out how much you spent on the lemonade. So that's your profit. So in our case, our revenue was 9x and our cost was the x cubed minus 6x squared plus 15x. So it's just x cubed minus 6x squared plus 6x. Oh, revenue. Yeah, I did. Thank you. Sorry, I don't like flipping back and forth. So 6x minus, was it 6x or 9x? Okay. So 9x minus, so this whole thing is x cubed. I'm looking at my y1 now, so I have it in front of me. Plus 15x. Okay, so I'm going to have 9x minus a 15x. So that's going to be negative 6x. So I'm going to have negative x cubed plus 6x squared minus 6x. Okay, so maximizing, I'm going to get negative 3x squared plus 12x minus 6. Find when it's set equal to 0. So pull out a negative 3. I'd have x squared minus 4x plus 2. Uh-oh. So what does this mean? So x equals negative b plus or minus b squared minus 4ac all over 2a. So you're ignoring the negative 3 out front. Okay, so I get 16 minus 8, so I'm going to have the square root of 8 there. So I have 4 plus or minus, square root of 8 is 2 root 2. So write it like that. You could just find the decimal version too if you want. So it's going to be 2 goes into both pieces, so I get 2 plus or minus root 2. So 2 plus root 2 is 3.414. And 2 minus root 2 is 0.586. Okay, we don't know which one's maximizing, which one's minimizing. Okay, if you think about your profit equation, let's see, so your p prime was negative 3x squared, so that's going down like that. So it's going to be, well, I don't know where it crosses. It's probably like crossing the axis like this. So it's negative, then positive, then negative. I mean, if you looked at it on your graphing calculator, you could probably tell that. But let's go ahead and see. So if I plug in, so 0.586 and 3.414. If I plug in 0, I get a negative number. I get negative 6. So negative. If I plug in 1, I get negative 3 plus 12 minus 6. That's positive. And if I plug in 4, I'm guessing I get negative. So it's down, increasing, decreasing. So what's the level that maximizes? Yeah, 3.414. Okay, was this in thousands of units? Yeah, x represents thousands of units. So if I have 3.414, what does that mean? Yeah, so 3,414 items. So that would be like the number of cars or whatever you're making. That would maximize your profit. Okay, and the last one, if you guys can do it, I'll give you a bonus point. So that's a tricky one. So do you guys want to try it now, or you can work on your homework too?